Alright, we're going to talk about similarity in right triangles. And to start, we're going to start with what the geometric mean is. So let's say we have two numbers, 5 and, 11. That works. So we want to find the geometric mean. That means, basically, we have 5 over x equals x over 11. So this is kind of a long way around to do this, but I'm showing you this is really what it means. So we cross multiply because this is proportion. So you get x squared equals 5 times 11 is 55. To solve for x squared, you're going to square root it. And square root of 55 is 5 times 11, so nothing you can factor out there. So your geometric mean is just square root of 55. That is your answer. So the short way to do that, let's pick some new numbers. Let's say we had the numbers 3 and 28. So geometric mean here, the shortcut here is just square rooting those two numbers multiplied. So square root of 3 times 28. Well, that equals 3 times 28 is 84. Well, here we can simplify square root of 84. So if we factor that, 84, we're looking for things like 4, 9, 16, anything that's a perfect square. So 4 will go into 84, 4 goes into 8 twice, 4 goes into 4 once. Now 21 wouldn't have a 4 or 9 that goes into it, so all we have is the 4 to take out. So the square root of 4 is 2, so that would be 2 square roots of 21. Alright, so let's look at some right triangles now. So I got the big right triangle there, and then I cut it down with a perpendicular line there, and found two smaller right triangles. So when you're looking at this, you have to pay attention to sides. If it helps to redraw these, you can. So if I was to redraw that smaller one, I'd have a 3 and an X. If I redrew the other one, it'd look like that, and I'd have an X and an 8. So we set up a proportion, so we could do this X over 3 equals 8 over X. So you notice this is kind of like what we just did with geometric mean. So we end up with x squared equals 3 times 8 is 24. We square root it. And so x equals the square root of 24. If we factor that, you could do 4 times 6. So square root of 4 would be 2. So that would be 2 square roots of 6. Alright, so we got another right triangle here, and we got to find x again. So if I redrew that the smallest right triangle there, we got 3 right triangles. If I redraw that smallest one, I'd have a 9 and an x. 9's kind of off the page there. Alright, and then the other one we know two numbers for would be the big one. So if I redrew that big one, kind of reposition it, I know my shortest side there is the x, and my hypotenuse there would be 15 plus 9, which is 24. So now I can set up my proportion. 9 over x equals x over 24. Notice we kind of have the same pattern here. So x squared would equal 9 times 24. Which would be 216. Then we're going to take the square root of 216. If I add that up, I know it's divisible by 2, but if I add that up, 6, 7, 8, 9, it's divisible by 3. If it's divisible by 2 and 3, it's divisible by 6. So 6 will go into 216. 36 times, and what you'll notice, 36 is a perfect square because it's 6 times 6. So if we square root 36 there, oh, I didn't put my square root sign in there. If I square root 36, I'm going to get 6. So my answer there would be 6 square roots of 6. So if it helps you to redraw the triangles like I showed you here, then do that. If you can picture rotating and manipulating these triangles without having to redraw them, that's fine too. It's just however you see things in your head. So do what works best for you.